Hi, hello guys, welcome back to my channel. It's really nice to have you guys here. We are going to learn something very interesting today, so please stay tuned. So we're going to be learning transformers in LLMs, right? So we want to know how AI learned to understand and respond to us. We want to know how is ChatGPT able to understand what we type and be able to make sense and give us good result. Okay, so you can see in our course module we've done a lot of stuff, right? So if you have not seen all of these videos, especially this, the last video, please go and watch it, right? So we've explored ChatGPT, right? And we say behind ChatGPT is we have LLMs, right? And behind LLMs we have the transformers. So the transformers are the brain behind LLM and the brain behind our chatbot, right? So that's why we want to explore it today to know how it works, so that we can really understand how AI learn to talk to us. Okay, the first thing of course is to define transformers. Okay, so transformers in AI, so there is transformers in electricity, that's different. Okay, so these transformers are type of AI architectures, right? They are used in models like ChatGPT, well, like this chatbot anyway. So they're used in chatbot like this and other LLMs, right? So we discussed LLMs in the last video. Please, if you have not watched that, please go and watch it. It's very important for you to watch that video to understand the context of what we are trying to do. Okay, so transformers are designed to read inputs when typed to ChatGPT. Transformers is the one receiving the input from you, and this one is the major aspect to understand the context of what you type. Like you say, the cat is running, right? So transformer will be the one to understand what you're trying to say. Okay, and based on that it will generate output. Okay, so we're going to see how transformer do this too. All right, so another point, transformer looks at the entire input at once, right? So that it can understand the relationship between all the words, right? So when you say the cat is running, transformer look at the word as a whole to understand the context of what we're trying to say. So based on that, this is different from other models that process text word by word. So there are also other models, AI models, that actually processes sentences word by word, right? But they will lose they won't be able to understand the context. But transformers actually process word as a whole. Okay, so the component of transformers, so there are three steps in transformer, right, that transformer use to understand word. So the first one of course is the input sentence, what you type. Then there's something called tokenization, I will explain it. Then there is embeddings, then there is encoder, there is decoder, and the result. So what we're trying to do today is to understand all of this. Okay, and you can see I have a very cool diagram in here for you guys. So for example, if the input is the cat is on the mat, right, then it will tokenize it, it will create embeddings for it, it will encode it, it will decode it, and it will be able to learn from it and also give you results. Very simple. The input sentence. Okay, so the first step is the input. So this one is just, this can be sentence read by transformer during the learning stage, right? So this is just what you put into it. So like the input can also, because the transformers actually learn before you interact with it, so the input can also be what the transformer read before. Like we talked in LLM that LLMs actually read a lot of text, right, to understand things, right? So the input text will also be what the transformer read, right, or read online, to be able to understand what we do. Okay, so it can also be a sentence asked by the user. So it can also be something that you ask transformer, right? So two things, the input can be something that the transformer learned from. The input can also be the question that people ask transformers. Okay, so please don't forget that. So the sentence will go through several stages within the transformer, right, model to produce response or understand the sentence, right? So the transformer will have to understand the sentence, and if you are asking the transformer question, it will also know how to give you response. Okay, so for our example today, we are going to be looking at one sentence, to see how our transformer actually work with this. So let's assume that our model read this sentence online: the cat is on the mat. Okay, so how will the transformer model learn from this sentence? That is what we want to do. Okay, so let's say the transformer read this sentence online. So how will it learn from it? Let's find out. Tokenization is the second step, right? So this is very simple. So tokenization is the process of breaking down the input sentence into smaller units called tokens. Each token is usually a word or subword. See, it's just breaking down sentence into words. That's all. Very, very simple. Okay. So in our example, the cat is on the mat. So the tokenized will be tokenized into this. So D will be a token, cat will be a token, is a token, on is a token, D is a token, mat is a token, and full stop or period is a token. So why do we need to tokenize? Because it's just breaking things down. Okay, so tokenization helps the model process each part of the sentence individually, right, which allows it to understand the relationship between words effectively. Okay, so transformer will break down sentence into words like read, and then try to understand how those words relate to each other. Yeah, because when transformer is trying to understand something, okay, so like when transformer is trying to answer a question, it's actually predicting word after word, word after word. So for it to be able to predict words to give you, it must have known like, oh yeah, this word are related to each other, then this should be the next word, right? So that is why transformer need to break down sentence into words, right, so that it can understand what it's trying to learn. Okay, so we can see, so each of these are actually tokens, right? So so that's why it's called tokenization. You can say break. You can actually call this break words, break sentence to word or something, right? But what you get after that is tokens. Each of these word will be tokens. Okay, that is good. So now we have an interesting thing called embeddings. Okay, please follow me, right? So embeddings are converting tokens into vectors. So the background of this is computers cannot understand word, right? Cannot process word. So we have to convert the words to numbers. That is just the basis of these embeddings, right? We need to convert words to numbers. Okay, so when we are done with tokenization, each word is converted into a vector. So vector means list of numbers, or if you are familiar with programming, is array of numbers. Okay, so each word, so for example, cat is converted to this number. Okay, so it's converted to a vector, a list of numbers representing each word. These vectors are called embeddings. That's all, right? So converting word to numbers is called embedding. We can call it encoding or something, but yeah. So embeddings capture meaning of each word in a mathematical form, right? Because computers only understand mathematics, right? So we have to represent it. So allowing the model to understand each token. Each token means each word, don't forget, in relation to one another, right? So when you represent one token with embeddings, then it can find the relationship between each token, right? So look at this. Words with similar meaning or context have similar embeddings. You see, that's how ChatGPT or LLMs, right, are able to understand the relationship between words. So for example, cat and dog might have embeddings that are closer than cat and table, right? You know, something like that. So you can see cat and mat, because in our sentence we said the cat is on the mat, right? So the cat and mat, we have almost the same embeddings, like close embeddings. You can see the embedding for cat is 0.2 minus 0.2, and it's going to go on depending on your architecture, right? but you can see they are almost the same. So when the AI or chatbot or LLM or transformer is giving you results, it knows that one way or the other, cat and mat are in the same sentence. So it can predict it when it predicts cat, then mat will probably come in future, right? Something like that. Okay, so that is how embedding works, and that is the reason why we need embeddings in transformers. So the next one is the encoder. So encoder is what we after we do the embeddings, then we do the encoder to understand context. So just follow. So the encoder's job is to understand the relationship between words in sentence. Okay, so we have these embeddings and this embedding and this one, right? Token embedding, token embedding. So now we want to understand how does this token relate to this using these numbers, right? That's what encoder is. So it does this using self-attention, which helps the model determine which words in the sentence are important to each other, right? So self-attention assign weight to each word, showing how much each word influence one another. So it will assign weight to this and this, right, and see if they are related to each other. So words that are related to each other will have higher weight. Words that are not related to each other will have lower weight. That's how it's able to predict what word is next when writing, right? So the difference between words, the weight between words is calculated by mathematical operation on their embeddings, right? So you do some mathematical operation on the embeddings, right, and see if these words are related to each other. And you can see here, so math, then cat, math. So the calculation is very complex math, so we don't need to worry about that, but it will do some operation and it will tell you, oh, the weight between cat and math is 0.8, so that means cat and math are related to each other. Then this one, cat and on, maybe the weight is this, so that means cat and math are related more than cat and on, something like that. Okay, so that's how the encoder works. So this one, embeddings, will represent each word or token with numbers, right? And when we have a lot of words with a lot of numbers, then we want to know which word are related, and that's what we use the encoder to do, right? To understand which word should come next. Again, when ChatGPT is writing something, it's actually predicting each word. Each word is doing a lot of calculation. Each word. So if ChatGPT says this is a dog, it will predict this is a dog. And how does it do that? By using these embeddings and encoder, right? So the next thing is, after you have your encoder, is to decode, which should be very easy. So you encode, then you decode. So the decoder takes the processed information from the encoder, generates a response one by one. Okay, so after the encoder has given you the relationship between words, right, and say cat and math are really related, their weight or their relationship is 0.8, cat and on, their relationship is 0.5, then the decoder will now take this information, right, and use it to give you output, right? So in generative AI, the decoder predicts each word based on the context from the encoder. So the context is actually the weight between words, right? Don't forget that. And the previous word it has generated. Okay, so the decoder will start with initial token like D and predict the next word, right? It predicts the next word by using what? Do you want to answer that? By using the result from here, which is the weight, right, to see how the tokens or the words are related to one another. So that is that. Okay, so just to put everything together for us to see it like as a whole, right? So the input sentence is the cat is on the mat. So this is sentence that the AI or ChatGPT or LLM or transformer is reading online to learn from. Then the next step is to tokenize it, break it into words or tokens. So each one of these actually token. Then the next step, because computer cannot understand words, is to break it down to represent a number, like or break each word to embeddings, which are numbers, right? And now the encoder will now be the one to use these numbers to see how words are related to each other. Then the decoder will now be the one to now use the weight that we get from here to predict word, right? So this process is a process at which by which the LLM, right, or the transformer learn from this, right? But now after the transformer has learned this, now let's say someone now say, oh, where is the cat? Then the LLM will now use this, what it has learned, right, and now say, oh, the cat is on the mat. And how does it do that? It used the decoder, right, to get the relationship between the words and say, oh, the cat is on the mat, right? That's how the whole process works, right? So hopefully that is really good for you guys to understand, right? It's very simple, you know, like all this step, and that is how ChatGPT is able to work, and it's able to create good responses, and it looks like magic. It's not magic, it's actually the whole of this. That is how it works. Okay, so that's the end of this class. Hopefully you guys were able to learn one or two things about how transformer actually learn from us, and also talk or chat to us like humans, right? So the next video we're going to be talking about prompt engineering, right? So this term might be new to you, but what prompt engineering is just how we can chat with AI to get the best result, right? So when you talk with humans, right, so you have to know how to talk with humans to get good response from them, right? The same way you have to know how to talk to AI, you have to know best ways to ask AI question, right, to be able to give you right response, right? Based on all of this, how the AI works, right? So based on this, we'll know what are the best ways or like the things to do to be able to ask AI question to be able to give us good response, right? Because the answer that you get from ChatGPT is as good as how well you can ask the AI question. Okay, so that's what we will do in the next video. And please, if you don't want to miss that, please like my video, subscribe and share. Please, if you are watching this video, please comment and like and subscribe and share with people, and I will see you guys in the next video. Bye.